Hello everyone. Today we are going to discuss here hydraulic actuators. So first of all, let's start here. So what is actuator? An actuator is a device that makes something move or operate. It receives a source of energy and uses it to move something. So what is source of energies? So there are different types of actuators. These are the four types also called as source of energies: hydraulic, pneumatic, electric, thermal, or magnetic. These are the types of actuators, and these are the source of energy. In hydraulic system, there are fluid is used. Okay. In pneumatic, there are air is used. In electric system is used. In thermal and magnetic, heat and magnet is used. These are the source of energy. So what is hydraulic actuator? The hydraulic actuator consists of cylinder or fluid motor that uses hydraulic power to facilitate mechanical operation. The mechanical motion gives an output in terms of linear, rotatory or oscillatory motion. As liquids are nearly impossible to compress, a hydraulic actuator can exert a large force. They convert hydraulic energy into mechanical energy. This is the main purpose of the hydraulic actuator. Next one is types of hydraulic actuators. There are two types of hydraulic actuators. First is linear actuator, second one is rotary actuator. So the already name suggests that linear actuator, we give an desired output in terms of linear motion. So linear actuators refer to the broad class of device that convert one type of motion, usually rectilinear or electrorotational, into linear motion. An unbalanced fluid pressure applied to the piston generates force that can move an external object. Since liquid are nearly incompressible, we know already liquid are impossible to incompressible. In air, there is some leakage, but in fluid, there is no any leakage. A hydraulic cylinder can provide controlled, precise linear displacement of the piston. The displacement is only along the axis of the piston. They produce linear motion as its output. So next one is single cylinders. This is the example of that linear actuator. There is only one cylinder. There is one port is provided. There is piston seal, piston, one rod, and between the piston and the rod there is a spring is provided. So if you apply a fluid pressure from the left side port, then piston move in the right side direction. You see here, piston moving in the right side direction with the help of that fluid pressure. When fluid enters from that port, then piston moving in the right side direction. That's called as extension stroke, and remaining fluid is passing through that vent port. So with the help of the spring force, the piston again return back to left side direction, and this is called as return stroke. So this is a working principle of the single cylinder, single acting cylinder. So next one is double acting cylinder. So in double acting cylinder, there are two cylinders, two ports. Here is one port. Here is one port. There is one rod, cylinder, piston seal. So if we apply the fluid pressure from the left side port, then that piston moving in the right side direction. That piston moving in the right side direction, that's called as extension stroke with the help of that fluid pressure. So remaining fluid is passing through that return flow. That fluid is passing through that port. So this is called as extension stroke. And if likewise there is same process, if we apply the fluid from the right side port, then that piston moving in the left side, and with the help of that's called as return stroke. This is the working principle of that double acting cylinder. So next one, double rod hydraulic cylinder. So in double rod hydraulic cylinder, the already name suggests that double rod. There are two rods are used. So there are two rods. Here is one rod, and right side is rod. So there is only one piston seal. There are two bolts. Same procedure, double reacting cylinder. Passing the fluid pressure, then piston moving in the right and left side direction with the help of fluid energy, hydraulic energy. So this is the double rod hydraulic cylinder. Next one is rotary actuator. So in rotary actuator, you gives an output in terms of rotary motion with the help of that source energy. We see already source energy. What is hydraulic, pneumatic, thermal, magnetic, electric? These are the source of energy. With the help of that source of energy, we convert the motion in terms of rotary motion. So rotary actuator is an actuator that produces a rotary motion or torque. An actuator that can something move in a circular motion, also referred to as rotating. They produce rotary motion as its output. So this is the main purpose of rotary vane actuators. So this is the example of that rotary actuator. This is rotary vane actuator. So in rotary vane actuator, there are two ports. So first P1 and P2. There is a stationary barrier. There is outer cylinder, actuator shaft, vane seal. You see here, actuator shaft, vane seal, stationary barrier. This is a P1 port, this is a P2 port. If uh, we applied the fluid from that port, okay, then that um, shaft moving in the clockwise direction with the help of that fluid pressure. There is hydraulic pressure, okay. So, and the remaining fluid is passing through that port in that direction, okay. So if likewise we are applying the fluid pressure from that P2 port, then that vane is moving in the anti-clockwise direction and remaining fluid passing through that port. This is the working principle of rotary vane actuator. So next one is single cylinder rack and pinion actuator. This is the example of that rotary actuator. So we see here there is one pinion, one rack, one cylinder, two ports are provided. So first of all, when we are applying the fluid pressure from the right side port here, we applied the fluid pressure from the right side here. Then with the help of that fluid pressure, that piston moving in the right side direction, left side direction, and remaining fluid is moving in that port. Okay, and with the help of that rack, that piston, that pinion is rotating in clockwise direction. So rotary motion is always, linear motion is converted into rotatory motion. Likewise, if we applying the fluid pressure, that with the help of that fluid in that port, then the track is moving in the right side direction and pinion rotating anti-clockwise direction. Okay, this is the working principle of the single cylinder rack and pinion actuator. So next one is double cylinder rack and pinion actuator. This is same procedure in single cylinder rack and pinion, but there are two rack are provided, there are two cylinders are provided, and only one pinion is there. Okay, so we see here, first of all, if we applying fluid pressure from the left side port, okay, then with the help of that fluid pressure is exerted on the piston, then that rack is moving in the right side direction. With the help of that rack, the pinion is rotating in the clockwise direction, and when pinion rotating clockwise direction, that rack moving in the left side. Okay, left side. And if we applying the fluid pressure from that port, okay, that rack moving in the left side direction, and with the help of the track, the pinion is rotate in the anti-clockwise direction. With the help of that pinion, that near the rack is moving in the right side. Right side direction moving that rack, and that there are two linear motion, one rotary motion. With the help of linear motion, the pinion is rotating the rotating motion, so converted into rotary motion. This is the working principle of the double cylinder rack and pinion motion. So in this presentation, we are discussed different types of source of energy. Source of energy like hydraulic, pneumatic, electric, and magnetic, and thermal. So these are the source of energy. These are the types of that actuators, and we explain detail the hydraulic actuators, their types, linear and rotary, and different types of their linear actuator and rotary actuators. Okay, thank you very much. Thank you.